Hello and welcome to our first section on polynomials. We're going to talk about graphing polynomial functions. A lot of stuff to cover. And some of it is a little challenging. So let's see what we can do. All right, so there are 5 things we want to talk about. We want to determine whether a function is a polynomial. So define what a polynomial is. Differentiate between a polynomial function and a function that is not a polynomial. We want to determine the end behavior of a polynomial function. We want to determine the behavior of polynomials with odd, even degrees. We want to evaluate a polynomial function at a given value of x. And we want to graph polynomial functions using a table of values. And that last part is going to be like putting together a puzzle. All right, so a polynomial is a function with many terms in the standard form. A x something to the power of something plus, and this is just subscript to locate the order, plus a subscript, so coefficient to the power of n minus 1, plus yada yada, plus some constant. So an example would be 3x to the 4th. And I'm going to do this in order in decreasing values of the exponent. 4, 3, 2. There's 1 here and then 0. So 3x to the 4th minus 2x cubed plus 0x squared. So this would be an empty, we call an empty term. You wouldn't write this out, but I'm just listing it here, minus 7x plus 4. Okay, so this is where x is x to the 0, which is going to be 1, is going to be your constant. All right, so I have decreasing values, integer values of the exponent. That's how you write it in standard form, from highest descending to lowest, or the constant value. All right, so what is a polynomial function? How do we define it? So n is going to be some exponent value, and that exponent value is not a variable, but we just say n because it could be any number. And whatever that number is, it has to be a positive integer. Can't be a fraction, and it can't be negative. X also, so x is going to be base here, has to be a variable and not a power. All right, so let's take a look at some examples. If I have x to the power of 1/2, this is a fraction. This is not part of a polynomial function. X to the power of -1 is a negative exponent. This is not a polynomial function. Same as 1 over x squared, which is really x to the power of -2. That's not a polynomial function. Some integer value to the power of the variable, that's not a polynomial function. If I have 1 over x to the -1, it's really x to the positive 1. That's okay. All right. So let's determine, I want you to pause here. Let's see if you can determine if these 4 polynomial functions are polynomials, or functions are polynomials or not. So pause this, and then let's come back. Oh. All right, so let's just do this on our own. All right, so hopefully you had a moment to look at these functions, and then we decided if they were polynomial functions or not. First one, yes, meets all the criteria, descending order, it's in standard form. Second one, no. I have, for the second term, I have, actually if I rewrite 1 over x, it's going to be x to the power of -1. And so I have a negative exponent as part of a numerator value for the variable. Third one, no, I have a variable as an exponent. And the fourth one, no, I have a fraction, non-integer fraction, as an exponent. So the first one, yes. Next 3 are going to be no. Okay, so let's take another set of problems. You can work along with me. Please pause this and do your work. And then I'm going to give you one to do on your own. Okay, so the first one, no, I have a negative exponent. Second one, yes, it's okay that this is a radical. It's okay that the coefficient's a fraction. This radical value is some constant, whatever it is. Next one, yes, this variable, this base 2 to the power of 3 is some number, as is 5.2, and I could either even say 3.5 would be fine. It's some constant value. And then even though this is a fractional exponent, this entire value is a constant. So if this base were a variable and this were a fractional exponent, then it would not be a polynomial function. And then the second one, no, I have an exponent that is not an integer, it's a fraction. So this brings us to classwork 4.1.1. All right, so you're going to do this on your own. I'm going to publish the answers to you in a separate format. So please write this down and submit it into the proper location that I define. All right, so let's move on. All right, so I need to talk to you about names of polynomials. You should know these names. Constant is just some constant value. It doesn't vary. Linear function, I have a power of 1, so 3x plus 2 is an example. Quadratic, highest power is 2. These are all polynomial functions. Cubic, highest power is 3. Quartic, highest power is 4. And quintic, highest power is 5. And these are all written in standard form. So you should stop, pause here, and write this down. And remember all these definitions, characterizations for polynomials. All right, so let's talk about polynomial definitions. The first term in standard form, right, I have the highest degree exponent, and then in descending order, I have a missing term of x squared. So the leading term is the first term with the highest degree. That defines what type of polynomial it is. It's a cubic. It's a third degree polynomial. It's an odd degree. The leading coefficient is 7. Right? Leading term is equal to 7x cubed. So the degree of the leading term is the degree of the polynomial. And the leading term is the first term in standard form for a polynomial. So you can write this down. I'm going to move on. And remember, you can always pause as I go through this. All right, so standard form of a polynomial, leading term is the highest degree exponent. Exponents decrease in order from highest to lowest. So this would be an example of a polynomial in standard form. This would be this would not be in standard form. However, these are both equivalent expressions, so they have the same mathematical value, but they're written in a different way. All right, so we say standard form, highest to lowest, with a degree exponent, and non-standard form is not in that order. Okay, so this is going to be classwork, not classwork for you, but work along with me. For each polynomial, rewrite in standard form, then provide the leading term, leading coefficient, the degree, whether it's odd or even degree, not function. We need to clarify. Pre-calculus, we'll talk about odd or even functions. So odd or even degree doesn't necessarily mean odd or even function. Don't worry about it for now. We're just talking about odd or even degree. So pause here and see if you can come up with the answer. I'm going to give you the answer now. All right, so the leading term, if I rewrite it in standard form, 5x squared plus 3x plus 2. 5x squared is the leading term. 5 is the leading coefficient. Degree is 2. It's a quadratic, and it's an even degree function. Next one, I'm going to rewrite in standard form, x to the fourth plus 3x squared minus 2x plus 7. My leading term is x to the fourth. My leading coefficient is 1. Fourth degree, this is a quartic polynomial, and the degree is even. All right, this brings us to classwork 4.1.2. I'm going to give you the problem. All right, so for each polynomial, rewrite in standard form, then provide the leading term, leading coefficient, and the degree, whether it's an odd or even degree, and then name the polynomial. Oh. Showed you the answer. All right, so I'm going to leave this up here for a moment, and then I'm going to move on. Okay, now we want to determine the end behavior of a polynomial function and determine the behavior of polynomials with odd or even degrees. All right, so end behavior of a graph means what happens to y as x goes to positive and negative infinity. All right, so if we take a look at this positive, or this polynomial, we see that as x goes to negative infinity, y is going to positive infinity. And so we write end behavior this way. X arrow negative infinity, so as I go to negative infinity, to the left of the x-axis, y is going to positive infinity. And so for me, by the way, I always write the positive down mostly, but it's assumed that it's positive if you don't write a positive value. But you have to write the negative sign if it's negative. On the same vein, as x goes to positive infinity, now we're going in this direction, y is also going to positive infinity. All right, so we're talking about end behavior. What's happening if you were to keep on moving in this direction and never stop? You would be moving towards infinity on the y-axis, and the same if you moved into the direction on the left, as the values got increasingly negative. All right, so odd or even, an odd function, let's say odd degree, I shouldn't say odd function, but odd degree function is either up, down, or down, up. An even degree function is either up, up, or down, down. Okay, so we're going to talk about quartic, which is a 4th degree, and cubic, which is a 3rd degree, pretty exclusively, mostly the cubics. And for cubics, 3rd degree, it's up, down, or down, up. And then for even quartic, up, up, or down, down. Okay. So 2nd, 3rd, and 4th degree polynomials end up having terns. Right? And I'm going to give you the 2nd degree polynomial. So we'll talk about 3rd and 4th. I'm going to have one turn in a parabola, in a quadratic, right? I turn here, it goes up. I turn here, it goes down. So turn is where you go from an increasing function, right, a positive slope, to a decreasing function or a negative slope, or vice versa, decreasing here to increasing here. Right? So I have one form. And then here is the end behavior I've listed. You can look at that, all right, on your own. So end behavior on the right, x goes to negative infinity, y goes to negative infinity. X goes to positive infinity. This should actually be y goes to, this case, y goes to negative infinity. And let's just double check here. This is correct. All right, let's move on. So 3rd degree is going to have 2 terns. All right. So I'm either going to be down, up, or up, down. And so, so a turn is where it goes, again, from increasing to increasing here, decreasing to increasing to decreasing. So as it changes from increasing to decreasing, that's the turn. And here I've had the end behavior. As x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. And similarly, on the right-hand side, as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to negative infinity. All right, so this is a 3rd degree polynomial. I have 2 turns here, and then the end behavior is here. This represents negative x cubed, and this represents a positive x cubed. Okay, 4th degree polynomials. I got up, up, or down, down. I have 3 turns, 1, 2, 3, generally. All right, so I have up, up. As x goes to negative infinity, y goes to positive infinity. This is the end behavior. X goes to positive infinity, y goes to positive infinity. This is down, down. I have my end behavior here. I have 3 turns. So one fewer turn than the degree value. So quadratic, exponent value is 2, turns 1. Cubic, exponent value 3, max turns 2. And then 4th degree, max turns 3, maximum number. Okay, so I need to clarify that an even odd degree is not the same as an even odd function. I might say an even or odd degree, that is a function, but it's separate from an even odd function, which you'll discuss in pre-calculus. Okay, so we want to write, this is going to be, going to turn into a classwork problem. We want to write the end behavior of this polynomial, state the degree, and whether the degree is odd or even, and whether the sign in front of the leading term is positive or negative. So you have to go back to, right, this discussion here. I had a negative x cubed. It's up to down. Positive is down to up. So you have to go back to these slides, maybe, and your notes to figure this out. So you pause here, and I'm going to come back and I'm going to give you the answer. So please pause and try to work this out. Okay, so we have the end behavior as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. The degree is 3. And the sign is positive because it's down up. It's a cubic. All right, I have 2 terms. Okay, let's try another one. Write the end behavior of this polynomial, state the degree, whether the degree is odd or even, and whether the sign in front of the leading term is plus or minus. So pause here. I'm going to come back and give this to you. Okay, so we have as x goes to negative infinity, y goes to negative infinity. As x goes to positive, y goes to positive infinity. It's a 4th degree. It's, we should say it's an even function. The sign is negative because it's down, down. Positive x to the 4th would be up, up. All right, that's it. We're going to come back and I'll give you another classwork problem. Thanks for joining us. See you soon.